Okay, welcome to a video lesson on applying the solving of an exponential function using logarithms in this particular application where we're talking about half-lives. So the half-life of strontium-90 is given as 28 years. And what that means is that after 28 years, if you have a sample of strontium, it is not stable. So it will change. In 28 years, only half of it will remain. That's what a half-life means. So if you start out at 100, let's say at 100 milligram sample, after 28 years go by, you would then have 50 milligrams, approximately. And then after another 28 years, you'd only have 25 milligrams. And then another 28 years, you'd have 12.5 milligrams, and so on. So that's what a half-life means. It would be every 28 years. It is cut in half. The amount remains. So this says, how long will it take a 72 milligram sample to decay to a mass of 18 milligrams? It says, use the general half-life formula, P sub n equals P sub 0 times 0.5 to the T over H. Now, the P sub 0 is the starting amount. P sub n is the remaining amount. So in half-lives, notice there's a 0.5 there. You're going to be multiplying by 1/2 or 0.5. So this P sub n is going to be getting smaller than P sub 0 because the amount in the sample is diminishing. So it says we're starting out with 72. That means we'll put 72 in for P sub 0. The half-life length is 28, so that goes in this position in the formula. And now it decays to a mass of 18. That is P sub n. So this value tells us what we have remaining. So that's going to be 18 is equal to 72 times 0.5 to the T over H. And H, of course, is 28. 28 years for half-life. So that means every 28 years, so if T is 28, then 28 over 28, of course, is 1, and that means you'll multiply 72 by 0.5 to the first power, and that would be half of 72, or 36. So if you solve this using logarithms, you're going to divide both sides by 72 so that we can isolate that exponential expression. And 18 divided by 72 reduces to 1/4, or let's write as decimal, I guess, 0.25, 0.25, is equal to 0.5, or just 0.5 to the T over 28 power. Now that is in the form, that's an exponential form like a to the c, where a is the 0.5 and c, the exponent, is T over 28. It's equal to 0.25. So let's go ahead and clear that up a bit. So to solve for this, we want to use logarithms. And remember, we take the base of the power becomes the base of the logarithm. So that means we'll get the log base 0.5 of 2.5, or 0.25, if you want to write that, should be equal to the exponent, which is T over 28. So you can use the change of base formula to estimate log base, or this will be an exact value, 0.5 of 0.25. Remember, you take the, to do that, you take the log, of the argument, the 0.25. I'm going to take the natural log or the common log, it doesn't matter, as long as you're consistent. Natural log of 0.25 over the natural log of 0.5. Take a minute, do that on your calculator. You should be getting the number 2. Basically, 0.5 to what power would give you 0.25, and that would be 2. 0.5 squared is 0.25. So that's T over 28. And now to solve for T, of course, we're going to multiply both sides by 28. We'll say that was 2 half-lives, which is 56 years. So it would be 56 years to decay into 18 milligrams. And what does that mean? That means, think about that, you start out at 72, and in one half-life, cut that in half, you get 36, and cut that in half, and you get 18. And that's why it was 2 half-lives. Half to there and half to there. And each half-life was 28 years. Okay, I hope that makes sense and helps you understand this a little better.